Hello everybody, in Module 2, I talk about feedback effects. Module 2 has 6 lessons. Today we're focused on Lesson 2. I'm going to use a simple example to illustrate the difference between price efficiency and real efficiency. Recall that in the previous lesson, we say that a key insight of the feedback effect is that it generates a discrepancy between price efficiency and real efficiency. In this lesson, I'm going to use a simple example to illustrate. I'm going to show there is an equilibrium with high price efficiency but low real efficiency. The model discussed in this lesson is a simplified version of the setting Dow and Gordon 1997 JF paper, which is one of the first studies to show that price efficiency is not the same as real efficiency. Now let's look at the setup of the model. There's a firm endowed with a project. The project requires an upfront investment of 1 at date 1. Once the investment is incurred, the project is going to generate a random return at date 2. The return is random from date 1's perspective. The realization of the return depends on some underlying state denoted by theta. The realization can equally likely to be H or L, with H is bigger than L. One can think about H as the boom period return and L as the recession period return. The firm can choose whether or not to invest based on stock price at date 1. So you can see in all feedback effect models, the firm has to make a real decision. In this case, whether or not to invest in the project. The decision is going to be made based on whatever information the firm can learn from the stock price at date 1. Date 1 trading occurs in a discrete Kyle setting, where the informed trader may not trade. As we discussed in Lesson 6 of Module 1, discrete Kyle setting is simple enough to incorporate other elements, for example, feedback effects. And we see an example here. The setting here is similar to the Gloston-Milgram setting that we discussed briefly, also in Lesson 6 of Module 1. The informed trader can learn perfectly about theta if the informed trader incurs some information acquisition cost of delta. The informed trader enters the market with some probability pi. An informed trader is going to trade either -1 or 1 shares, depending on the informed trader's observation of theta. The uninformed trader, which is also equivalent to liquidity trader in this setting, enters the market with the complementary probability 1 minus pi. An uninformed trader is equally likely to trade -1 or 1 shares. The uninformed trader's trade is independent of information. The order flow S can thus be either -1 or 1. Now we're going to make some assumptions here. The first assumption states that in the absence of any information, the project is negative NPV. We're going to see that this assumption is crucial for the wedge between price efficiency and real efficiency. To see why this assumption implies negative NPV, note that in the absence of any information, we rely on prior beliefs. The prior belief is that the return is going to be H with probability 1/2, and is going to be L with probability 1/2. So the expected return of the project is H plus L divided by 2. That's smaller than the cost of the project, which means the project is negative NPV. The assumption 2, we're going to see why we need this assumption soon. It means pi has to be sufficiently large. Intuitively, it means that the probability of the informed trader being present has to be sufficiently large, so the price is sufficiently informative such that the firm is going to learn from the stock price. Assumption 3 states that the trading profits from information acquisition is higher than the information acquisition cost. So that means information acquisition is going to be profitable for the informed trader. So the informed trader may involve information acquisition. Let's look at the results. There are 2 equilibrium. In the first equilibrium, the informed trader does not acquire information. The firm is not going to invest in the project, and so the price equals 0. In the second equilibrium, the informed trader acquires information, the firm learns from prices, and the firm is going to invest in the project when the order flow is +1. To see why the first one is an equilibrium, note that if there is no information to be learned from the stock prices, the firm is not going to invest because assumption 1 states that absent any information, the project is negative NPV. And if the informed trader knows that the firm is not going to invest, they're not going to acquire information because price is going to be equal to 0 for any order flow. And so there is no trading profit because information acquisition is costly. The informed trader is not going to acquire information. To see why the second one is equilibrium, know that if traders acquire information, then price is going to have information content. When the order flow is -1, the price is going to be 0 because the firm is not going to invest in the project. The reason is that the order flow being -1 would either come from informed trader who gets bad news and trade -1, or uninformed trader just randomly submitting -1. In the case of uninformed trader, there's no information, and we know the project has negative NPV. In the case of an informed trader who gets bad news, the return is even lower. So the project has even more negative NPV. So the firm is not going to invest either. So that's why price conditional order flow B -1 is 0. To calculate the price when the order flow is +1, again, we need to use Bayes' rule, because theta is an exogenous variable. We can calculate the posterior belief that theta equals H conditional S equals 1, and that equals 1 plus phi divided by 2. The algebra provides a step-by-step guide applying Bayes' rule. I'm just going to mention why the probability S equals 1 conditional theta equals H is pi plus 1/2 times 1 minus pi. Conditional theta equals H, S can be 1 under two cases. The first case is the informed trader is present. The informed trader observes theta equals H, and of course, it's going to trade one share. That happens with probability pi. The second case is there is an uninformed trader. An uninformed trader randomly chooses S equals 1. The probability of the second case is the probability that the uninformed trader is present, 1 minus pi, times the probability that the uninformed trader randomly chooses S equals 1. And that happens with probably 1/2. So that's why the probability of the second case is 1/2 times 1 minus pi. And you sum up the probabilities of the two cases, you get the probability S equals 1 conditional theta equals H. So if the firm chooses to invest, we can calculate the expected payoff minus the investment cost based on the posterior belief. And this is positive, which means that the firm is going to invest in the projects. We can also calculate the informed trader's expected trading profits. The informed trader is only going to profits when the informed trader observes theta equals H, which happens probably 1/2. Conditional theta equals H, the informed trader is going to place an order flow +1. So the informed trader's trading profits in this case is the realization of the return from the project H minus the investment cost 1 minus the price that the informed trader is going to pay for trading order flow equals 1. And this expected trading profit is bigger than the information acquisition cost from assumption 3. So the informed trader is going to acquire information. So we therefore have two equilibria. What we can see in the first equilibrium, the firm value is lower because the firm value is always 0. The real efficiency is lower. The reason is because the firm does not invest in a case when information indicates that the project could be positive NPV. So we can see here in both equilibrium, prices are strong form efficient because prices reflect all the available information, including private information. So the price efficiency is the highest in both equilibrium. But in equilibrium 1, real efficiency is very low. And in equilibrium 2, real efficiency is high. So price efficiency is not the same as real efficiency. The reason is that you could have self-fulfilling inefficient equilibrium. In the first equilibrium, the firm is not going to learn from prices. And conditional firm not learning prices, the informed trader is not going to acquire information. And so price does not contain information. So that becomes self-fulfilling. We can see here the feedback effect is crucial because if firms never learn from prices, the informed traders do not have incentive to acquire information. So to conclude, price efficiency is different from real efficiency. Real efficiency depends on how much decision useful information is incorporated in the prices so that the firm can make better real decisions. But price efficiency only depends on whether price reflects all the available information. So if traders choose not to acquire information, then price is going to reflect that there is no private information in the price. So price efficiency is going to be high, but real efficiency is going to be low. In the next lesson, we're going to show how considering feedback effect can result in asymmetric trading. You have incentive to acquire and trade on good news, but less incentive to acquire and trade on bad news. If you want to test your understanding of this lesson, try the review quiz in this link provided by the slide. Thank you very much.